Hello and welcome to Resource Review. We're here at the Science Museum to bring you expert analysis and classroom trials of those essential resources. Today we're focusing on secondary science. Joining me to recommend today's resources is Nathan Goodman, Head of Physics at South Hunsley School in East Yorkshire and the Institute of Physics Teacher Network Coordinator in Hull and East Riding. Alongside Nathan, we have Adrian Fenton, Curriculum Support Manager for the Association for Science Education. Also on the panel is Karin Parker. Karin is Head of Science at Grange School in Bristol. Well, welcome to you all. Thanks for coming. Now, Nathan, there's a new secondary science curriculum coming in 2006, and your school actually took part in a pilot for OCR's 21st Century Science specifications. All the resources that you recommended for us today, are they going to help teachers with this new curriculum?
The air motors, which we'll be looking at in just a moment, I chose these ones here. They're really good for attaching attention, and it fits into the additional modules in Year 11, what was called the General and the Applied. And the magnetism one, again, magnets are still in the new specification. OK, well, let's start then with the air engine racer. Can you explain it to us and why you chose this one over anything else that's available? Mainly, you can't really get anything else like it on the market. Very simply, you can use it for energy transfers and forces, and it's entertaining. It's a lot more entertaining for the students than a banged out trolley rolling down a slope, which is what you normally use for energy transfer into kinetic energy. Right. And it's very versatile, so you can use it from Key Stage 3 right through to Key Stage 5. Well, before we discuss the resource any further, let's see it in action. We raced over to John Cabot City Technology College in Bristol, where Head of Science, Ros Strickland, and her Year 11 science group put it through its paces.
We'll pump it up 10 times. I get the same person to pump it up each time. The class I had today, they are Year 11, Key Stage 4, so they'll be doing their GCSE physics in May of this year. We were using the air engines today. We talked through all the physics of it, we talked through how an engine works, we talked about the forces involved in making an engine like this move. We talked about conservation of momentum. This thing here is called an anemometer. It measures wind speed. So what we'll do is pump it up 10 times, hang on to it, you can hold it in front, tells the wind speed. The air engine, it's a proper little engine. It's got the pistons, it's got the valves, the propellers. It's very similar to an internal combustion engine on a car, just a bit smaller. Every table has got an air engine. There's two versions, blue ones, green ones. The main difference is the green ones are more powerful. Don't get upset, those people with blue ones. So I want you to come up with some sort of rudder system or, well, anything you like, basically. But I want something that you can attach to it that you can actually make it turn.
We just made a spiral design to fix on the end of this. So when the air gets forced back, hopefully the air will hit this like rudder and then get the air force here so the plane will move that way.
For topics like this, forces, momentum, it's usually very theoretical. Most of the experiments that you've got involve the traditional sort of experiments, trolleys and runways and ticker tape timers. Don't tend to work that well. Right, we're ready to test. Finished or not, time to try them out. I think it ties in very well with the new curriculum, because the new curriculum is all about making it more real, making it more applied. Go on, give it a try, give it a try. I think it's very well designed, yes. I thought it was excellent value. The only thing I think you'd have to be a bit careful about is just how robust it is. I'd be interested to see how long they last.
Well, Nathan, the air engine racer certainly looks like a really fun resource. But do you think that a class is really going to learn enough from using it? Aren't they just having a bit of fun?
Well, they are having a bit of fun, and that's the beauty of it, but as long as the teacher's making sure that they're covering the physics as they go, they will learn a lot from it, and they'll remember it which of course is going to make the lesson far more successful than if you use a traditional method and you talked about the forces involved with something that's less inspiring.
Because I would have thought this is perhaps more appropriate at a much lower level because of perhaps the way it looks. But did you see older pupils responding to it well?
The older pupils responded well, as did the younger students. We've used it for induction days for Year 6 students. You know, they come in and they really get a buzz out of science.
Right, OK. Karen, can you see this as a resource that you might use in your school?
Yes, definitely. I think once the staff have finished playing with it, it can go through light gates, you could put some ticker tape onto it, something like that, so you could get a lot of the maths out of it, as well for more traditional physics.
Oh, that's interesting. Now, do you think it's well priced? I mean, the kit here we've got is about £12.
£12 for a kit, definitely trial it. I don't know about a class set, but ideally that's what we'd end up going for.
OK. So. Now, Adrian, how do you think this resource is going to help with the new curriculum?
When I saw it first of all, I thought, well, OK, how's this really different to a balloon rocket? You know, it's a bit of a sophisticated version. And Nathan quite rightly said that, you know, there's other ways that you can use this across the whole spectrum, applying it. In that sense, by showing that physics can be applied and it's sort of relevant to the movement of the vehicles and things like that, and it's not just a theoretical idea that's being explained, then you know, it's adding something more value to the actual piece of kit itself.
Karen, is it more of a toy, less of a teaching tool, or do you really like bright things like this in the classroom?
Does it matter? Toys are just devices to interpret science. Okay. So it's a good teaching tool.
Yeah, well, a very good recommendation there, Nathan, for the first one. Right, well, let's move on now to our second resource. It's called Ferrofluid, and I think there's some of it in here. Nathan, what is it, and why did you choose it?
Right, well, it's very simply, it's a liquid which is magnetic. So I chose it because I've never seen anything like it before. And it comes in a tub like that, but if you take it and you put it in a test tube with a bit of water, you can demonstrate magnetism from a distance, and you can move it up and around, where you would normally use iron filings, which can be a bit awkward, they get everywhere. Whereas this, it's all sealed up, and you can very simply just move it around. It's just quite fun, really.
Yeah, it looks fantastic fun. Well, thank you very much, Nathan. Another fun-looking resource. And to see it in action, we went back to John Cabot City Technology College in Bristol, where teacher Mark Allen is using it with his Year 9 class.
The class I had today is Key Stage 3, Year 9. It's a mixed ability group. Today's lesson is about magnetism. The first objective for this lesson is to understand what magnetism is. You're very familiar with these kind of things, aren't you? These bar magnets. Well, I'm going to demonstrate something to you now, which is a liquid magnet. I want to show you how it works and the sort of things that we can do with it. It's a sort of modern use, future use of magnetism, if you like. Come around and have a look at this. The resource I was using today was a ferrofluid. It's basically a magnetic liquid, quite unusual, something which the students haven't seen before. Now I'm going to demonstrate the sort of things that it can do in a little while, but I want to try and think about how can a liquid be magnetic. The way it works really is that when the ferrofluid has a magnetic field applied to it, it changes its density and allows a heavy object like a coin to float on it. Now, when I switch on the electricity, you should get a glimpse of it just trying to actually come up to the surface. Yeah? OK, let's see if it works. One of the downsides of using the ferrofluid is that it's very untidy, it's very messy. Throughout the demonstrations, I had to wear gloves because it stains just about everything it comes into contact with. The demonstrations that you actually are going to show really need to be sealed in some way, really to be practical. And that does limit some of its uses. So really the trade-off is actually showing something that can stimulate their interest and enthuse them, but yet, you know, they can't really play with it themselves. Would I buy the resource? I think it's worth having in a science department. Yeah, I think it is. I mean, judging by the reactions of the students today, they were interested in it. And so really that's, you know, if a demonstration is going to conjure up interest and a talking point, it's worth having around.
Well, Nathan, a really fun, innovative substance there, but my first reaction to seeing the video was, oh, what a mess. I mean, would you let it loose on students?
No, I personally wouldn't let it loose on students. I'd give them it in a sealed container that they could not open, because if you get it everywhere and they get it all over the clothes, it's not going to come out. So certainly would use it for demonstrations, perhaps get a small camera and project it so that all the students can see easier. But wouldn't let the students handle it themselves.
No, no. I mean, Karen, what did you think? Something fun for teachers?
Oh yeah, I think it's great, and I think it can be used to show the 3D nature of fields, but it's really hard to see. I have to be up close in order to show that. You can see some spikes in there.
Yeah.
So you'd need a flex cam, you'd need to project that somehow or pass it around, and I think get a bunch of physics teachers together, we'll come up with probably 18 different experiments to do with it.
Adrian, what do you think? Again, a very new, innovative resource here, helpful for the new curriculum?
Yeah, I think so. I mean, with the emphasis on how science works that's coming out through the new GCSEs in 2006, really the question's just, what is this? What's it doing? Why is it doing this? How do you reckon it could be used then? If we just said today we're going to talk about ferromagnetic fluids, I don't think many students would be impressed. But if you use the tool as the kind of thing to draw them in and to get them thinking about science, then it doesn't necessarily have to be a messy kind of class practical type situation as well.
Well, thank you all very much. And now let's move on to the third resource that Nathan has recommended, and that's the Badger Publishing Key Stage 3 Science Starters and the Level Assessed Tasks. So, Nathan, why these? What are they, and why did you choose them?
Well, we chose these because they'd been used they were piloted in schools before publication. They were written by teachers. The starters are just science starters, a big collection of resources that the teachers could use in class. The level assessed tasks are more useful in that they have targets for students, they can be used for assessment, but they can also be used so that not just for finding out how well the students know, but what the students need to do to improve. So it's very good for assessment, for learning, formative assessment.
Is there a danger that some teachers might become too dependent on them?
That is a danger. I mean, some teachers may decide every lesson start it with one of these worksheets, which, as well as the cost implication, could switch off the students really if they just get given a piece of paper at the beginning of every lesson.
I mean, just a final comment from you, Karen. What do you think of this type of resource?
I think the starters are an excellent resource to have in the background. I'm really interested in the level assessed tasks, very much so.
Okay, and Adrian?
They're good as a backup. A lot of LEAs have done some work in collating ideas to do with starters already, so also have a look at them, but obviously this is saving time.
Well, thank you all very much. That's all we've got time for. But to summarise today's resources, we've looked at the Air Engine Racer Kit from Middlesex University Teaching Resources. Next, we examined Ferrofluid, also from Middlesex University Teaching Resources. And lastly, the Badger Key Stage 3 Science Starters and Level Assessed Tasks from Badger Publishing. As usual, you can find more information about all of the resources we've discussed today, and you can also post your own comments about other resources for secondary science on our website. It's teachers.tv/resource review. And if you'd like to, you can email us, resourcereview@teachers.tv. So a very big thank you to our panel, to Nathan, to Karen and to Adrian, and thank you for joining us. We'll see you next time on Resource Review. Bye-bye.